These are the notes over graphing to solve systems of equations, a review for the 8th grade. So we've already done graphing to solve systems of equations this year. This is the same thing that substitution and elimination and Cramer's rule end up doing. What we're doing is we're graphing both equations they give us, because that's what a system of equations is. It's two equations put together. It could actually be more, but we're just going to focus on two equations. And what we're doing is we're finding the point x comma y such that in both equations at the same time I could end up making the left side of the equal sign equal the right side of the equal sign. And when you do this by graphing, as you recall, or hopefully you recall, what we're ended up looking for here is the point at which the graphs cross or overlap. So let's go ahead and take a look at the examples here with that brief tutorial in mind. Again, this is a review. We've already done this grading period, so hopefully it should be up in your head still anyway. First one here, we've got y equals 2x and y equals negative x plus 3. Now what's nice about both of these equations is they're set up in slope-intercept form here. So we're graphing these according to the techniques of slope-intercept form. So what you see at the top here is the graph of y equals 2x. Now, you may not recognize this as slope-intercept form because it's missing the b value. But rest assured it is slope-intercept form because we can go ahead and tag on a plus 0 to the end of this equation. As you know, adding 0 to the end of an equation, or adding 0 to anything, doesn't actually change what it is. It still is whatever it starts off as. So y equals 2x is the same as y equals 2x plus 0, which is what they're explaining in the first line here. Once you do that, and that's valid slope-intercept form, valid in that it looks like what you would expect it to look like, and then we can graph according to that technique that we saw yesterday. Since the number at the end here is 0, we're going to go ahead and put a dot through the y-axis at 0. So as you can see, that's where they started here by putting this dot right here. And then they went and grabbed the slope. Now the slope in this equation is 2, or fractionally 2 over 1, because remember, slope always has to be a fraction. So the slope of 2 over 1 means I'm going to rise 2, go up 2, and run 1. So from the point I just made, I'm going to go up 2 and right 1. Now you might be looking at this and realizing there's a lot more x's there than just that 1. You can repeat the technique of using the slope over and over and over again. So they decided to go up 2 and right 1 again, and up 2 and right 1 again, and up 2 and right 1 again. You can do that as many times as you want. And after they've done that all those times, they go ahead and connect all our marks there, and we end up with the graph of y equals 2x plus 0.